Hello and welcome to EduSathi. Let's discuss the topic of algebra now. In algebra, we'll be talking about algebraic expressions and polynomials in the first lecture. Then we'll move on to the second lecture and we'll discuss about linear equations and simultaneous equation. In lecture number 3, we'll talk about quadratic, cubic and higher degree polynomials. In lecture number 4, we'll talk about the concept of inequalities. We'll move to coordinate geometry in lecture 5, followed by functions in lecture 6, logarithms and exponentials in lecture 7. We'll study the concept of maxima and minima in lecture 8, and we'll end it with the 9th lecture with the concept of arithmetic progressions and geometric progressions. So let's get started and look at the first topic, which is the topic of algebraic expressions. Now what you have on your screen is what an algebraic expression looks like. An algebraic expression is a combination of numbers and one or more variables. Variable. That is the first word which is very important when we are understanding algebra. Variable. In the algebraic expression that I have written, x and y are variables. Variable means whose value keeps on changing. The value is not fixed. The value will keep on changing depending upon the situation. The next thing that you need to understand is constant. As opposite to variable, a constant is something whose value is fixed, whose value does not vary depending upon the situation. It will always remain the same. So this 10 here is a constant. His value does not change. All the other terms that we have, the value keeps on changing depending upon the value of x and y. So all of the others are variable, whereas 10 is a constant that we have. The next thing that we need to understand is coefficient. 4, 11, 5 and 7. These are the coefficients of the different variables that we have. That means the variables would be multiplied with the coefficients to get a term. And the last thing that we need to understand is the power. Power. Variables are raised to some power, like x square, y cube, x raised to power 5. This power of a variable is very important in determining the nature of the algebraic expression. The highest power of any expression is known as its degree. So degree refers to the highest power of any variable. If I have 2 variables or if I have 3 variables or a single variable, I will look at the highest power and that will refer to the degree. So if I look at this algebraic expression, the highest power of this will come out to be 4. X square and y square. There are 2 different variables which are in multiplication and the powers are 2. So I'll just combine them and I'll look at the highest power, which will be 4. The power for this term is 3. The power for this term is 2. The power for this term again is 2. Because x into y, there are 2 variables which are getting multiplied. So, and the power for this variable will be 0. So, whatever is the highest power of this, any term, that will refer to as degree. So, the degree of this equation would be 4. So, the polynomial can be classified on the basis of degree. Degree I've just discussed about. Degree is the highest power of any algebraic expression. If the degree is 1, it will be a linear equation or a linear polynomial that I will have. If the degree is 2, the expression would be referred to as quadratic expression. If the degree is 3, it will be termed as a cubic expression and so on. So, degree of a algebraic expression is very important in determining the type of expression and the graphical, you can say the graph of that expression. On the basis of number of terms, a algebraic expression can be classified as monomial. That means there's only one term. Now I'm not talking about the degree of that term. It could be a linear, it could be a quadratic, or it could be a cubic. If the number of terms are 2, it will be termed as binomial. If the number of terms in an expression are 3, it will be known as trinomial, and so on. So an algebraic expression is basically classified on two things. One is the degree, another is the number of terms. Number of terms and the degree. So let's move ahead and let's look at certain other properties of algebraic expressions. Let's look at two algebraic expressions, 2x plus 3y and 3y raised to power 4 plus 4y. Now if I look at this, here there are two variables, the two variables x and y that I have, right? X raised to power 1 and y raised to power 1, they are in plus. So the power is 1 and the power is 1. The degree of this equation will come out to be 1, and therefore it will be termed as a linear equation or linear expression. Now if I look at the number of terms are 2. So it will be like a linear equation in two variables. So this will be a linear in two variables. The variables that I have are x and y. If I look at the second expression, it is only one variable. It is only one variable which is used in both the terms, which is y. If I look at the first term, the power is 4. The power here of y is 1. So it will be an equation of degree 4. And it will be not be a linear thing. It will not be a quadratic or a cubic. It will be a 4-degree polynomial in one variable. So the variable is only one, which is y, but the highest power of y is 4, and there are two terms in both of these expressions. So there are two terms that I have in both of these expressions. So if I talk about coefficients of these two terms, the coefficients would be, if you look here, for the first thing, coefficient of x is 2 and coefficient of y is 3. For the next thing, the coefficient is 3 for y raised to power 4 and 4 for y. So all of these 4 are termed as coefficients. Now when you have to add or subtract two things, now for example I add the two things, so it will be 2x plus 3y, which is the first algebraic expression, plus 3y raised to power 4 plus 4y, which is the next algebraic expression. If I have to add it, I will only add up the terms which have the same powers. So my answer will be 2x plus 7y plus 3y raised to power 4. I can add or subtract. So if I now subtract the two expressions, the terms only which have the same power. So I will have 2x minus y, I will subtract 3y and 4y, and I'll get minus y minus 3y raised to power 4. So this is what you get when you add the terms, and this is what you get when you subtract the term. Addition and subtraction will happen for similar powers, and I should say similar powers and variables only. So if the power is same and the variable is same, it is x, then only you can add or subtract the two things. Otherwise you can combine the coefficients, otherwise the expression will be written, the rest of the expression will be written as such. When you have to multiply, addition and subtraction we have already learned. Let's look at the case where we are multiplying two algebraic expressions. Now here I'll multiply all the terms. So 2x into 3x, this will be basically 6. The coefficients would be multiplied and the powers would be again. So it will be like 2x into 3x, this 2 into 3 would be 6, and x into x. When bases are same, powers are added. So x raised to power 1 plus 1, it will be x square. Then this 2x will be multiplied with this 4y and plus, because there is a plus between all of them. 2x into 4y, this will be 8xy plus 3y into 3x. So coefficients will be multiplied separately and variables will be multiplied separately, plus 3y into 4y. So this will be 12y square. If I look at it, this xy and xy, the coefficients can be combined, and the answer that you would get would be 6x square plus 17xy plus 12y square. This is how you multiply two algebraic expressions. Division of two algebraic expressions. So if I give you an algebraic expression, now if you look here, this is a quadratic expression. Quadratic because the degree of this thing is coming out to be 2. The highest power of a variable is 2. Here it is 1, 0, so the highest power is 2. And if I divide it by x minus 2. Now how you divide it with x minus 2? There are two ways that you can go about it. The first is, let's look here, 3x square plus 4x plus 3. And you are dividing it with x minus 2. Now you look at this x and you look at this. So I'll multiply it with 3x. The first term that I will get will be 3x square. Now if you look at the second term is coming out to be minus 6x. Now if you subtract it, this will getting cancelled out. So subtracting means this will actually get added. So you will get have 10x plus 3. Again if you multiply it with 10. So x into 10, it will give you 10x and this will give you minus 20. So if you look at it, this 10 and 10 will get cancelled out and this will give you a thing which is 23. So if I look here, when I'm dividing this with this, it is not giving me only a quotient, but it is also giving me a remainder. So this 23 here is the remainder. So when you get a remainder, that means x minus 2 is not a factor of the given thing that you have, because had it been a factor, I would have got a remainder of 0. But since I have certain remainder, this number, that means your dividend that you have is equal to divisor into quotient plus remainder. So there is a remainder of 23. The quotient that you get, the divisor is x minus 2. The quotient that you get is 3x plus 10, and the divisor was this number that you started up with. Let's look at the concept of zero of a polynomial. Now this is very, very important concept, because this will be widely used when we are doing the concept of quadratic expressions. Zero of a polynomial. Let me give you a polynomial. This is a polynomial that we have given you. Now this polynomial, if you look at it, it has one variable which is x. 1, 2, 3, 4. There are 4 terms in this polynomial. Poly means many. And nomial means term. So an expression of many terms would be referred to as a polynomial. And if you look at the degree of this equation, the degree will be, the power is 3 here, it is 2 here, it is 1 and it is 0. So the highest power is 3. So the degree of this term will be 3. So that means this is a cubic expression or a cubic polynomial that we have. So if I put any value of x as an input, x will be an input variable or an independent variable. So the value of x that I want, I can take as anything, independent variable. When I put in the value of x, I compute the thing and I get the value of fx. Here fx is your output. Okay. So what is zero of a polynomial? If I put different values of x, let me start with x is equal to 1. If I put x is equal to 1, the expression would be 5 into 1 cube, which is 1, minus 2 into 1 square, which is be minus 2, plus 2 minus 5. If I solve this thing, the output that I am getting is coming out to be 0. Such an input for which the output comes out to be 0 is known as 0 of a polynomial. So for an input value of x, which is also known as an independent variable, the function or the expression is computed and the output that you are getting is actually equal to 0. Such an input will be known as a 0 of a polynomial. It is also known as root. So if I call 0 of a polynomial or if I call root of a polynomial, it is one as the same thing. Now, for other values of x, let me take x is equal to 2. If I put in the expression, it will be 5 into 8 minus 2 into 4 plus 2 into 2, which is 4, minus 5. If I just solve this out, this is 40 minus 8 plus 4 minus 5. So if I just compute these values, so it will be minus 4 that will have here and minus 5, so minus 9. The value of output is not coming out to be 0. Such an input will not be known as a root of an equation. This will be, if you put 2 as your input, the computation happens and you get an output. At an input where the output comes out to be 0 will be known as root or a 0 of that polynomial. The maximum number of roots for an equation will depend upon its degree. So if the degree of an expression is 3, the number of zeros or the number of roots that I'll have would be 3 roots. If it's a quadratic equation, that means the degree of the polynomial is 2, it will have 2 roots. That means there will be 2 values of input where the output gives 0 or where the output comes out to be 0. Let's move ahead and let's look at the remainder theorem. Remainder theorem is actually an extension of the 0 of a polynomial that we have just studied. So let me give you an expression. This is an expression that you have. I put an input where the output is not coming out to be 0. So whatever is the output which is coming out to be is the remainder. So if I have to divide this expression with x minus 2. So if you just remember, I have given you an example when we have actually divided an expression with another expression. So this is the question that we have, and I have to divide it with x minus 2. If x minus 2 completely divides this, that means if x minus 2 is a factor of this, my remainder would be 0. If x minus 2 is not a factor, if it's not a factor, there would be certain remainder that I will have. So if I have to check this thing, what I'll do, if x minus 2 I have to check, I'll put x is equal to 2. So if I put x is equal to 2, that means I will take x is equal to 2 as my input. So if I just put here, this will be 2 cube plus 6 into 2 square, which is 4, minus 19 into 2 minus 24. So if I just put these values, this is 8 plus 24, which is which can be cancelled with this 24. So this will be 8 minus 19 into 2, which is 38. I'll get a remainder of minus 30. So x equal to 2 is such input where the value of output is coming out to be minus 30. Minus 30 would be a remainder when px is divided with x minus 2. So it's a very, very simple thing that we have. So if x minus 2, I divide it, I'll get a remainder. If it is a factor, remainder would be 0. If it is not a factor, whatever is the value of output which is coming out to be is the remainder that we have. So factor theorem, if I talk about, if I give you an expression which is the same expression, and if I divide it with x plus 1, that means division with x plus 1 means I will put x is equal to minus 1. Minus 1 cube minus 1 square plus 6. This will be plus 19 and minus 24 that I have. the remainder would come out to be 0. That means x plus 1 is a factor of the given expression that we have. So, if you look at it, x is equal to minus 1 will be termed as the root or a 0 of this polynomial. So, if x is equal to a is giving me a remainder of 0, that means x minus a will be a factor of the given number. Or if x minus a is a factor, x equal to a will be a root or a 0 of the given polynomial. Let's look at certain questions, and that will help us clear the doubts that we have in case. If x plus 1 is a factor of this polynomial, now it is given that this is a factor. Now if this is a factor, that means x is equal to minus 1 will be a 0 of a polynomial or a root of a polynomial. That means the value of output at x is equal to minus 1 would be 0. So if I put it in the expression 2 minus 1 square plus k into minus 1 plus 3, my output would be 0. So if I just put there, this will be 2 minus k plus 3 is equal to 0, or the value of k that I will get would be plus 5. So for k is equal to plus 5, the expression would turn out to be 2x square plus 5x plus 3. So this is the expression that turns out to be x plus 1 is a factor of this. That means x plus 1 or x is equal to minus 1 is a root of this quadratic expression that we have. Let's move to the next question. The question is, if x plus 3 is a factor of the polynomial, again it is given that it is a factor, then the value of p is. Similar question, I'll put x is equal to minus 3. So minus 3 cube, which is minus 27, plus p, 3 square, it is 9p, plus 3 into minus 3, which will be minus 9, minus 9. Now this output, the final value that I will come would be 0 because it is a factor. So factor means x is equal to minus 3 is a root of that equation. That means the value of output when x is equal to minus 3 is your input will turn out to be 0. So this is minus 27, minus 9 and minus 9 equals to. So I can write 9p here. So the value here would be 27 plus 8. So the value of p would be, divide this expression with 9. You can also split it into part. This will be 3 plus 2. So the value of p that comes out to be is 5. Let's look at another question. What is the remainder when this is divided with x plus 4? So I have to check the remainder with x plus 4. So I will put x is equal to minus 4 in the expression. What is the expression that I have? 4x cube minus 3x square plus 2x minus 4. So I find out the value of output at input, which is minus 4. Minus 4 cube, so it will be minus 64. So minus 4 into 64 minus 3, 4 square 16. This will be minus 8 minus 4. If I look at it, so this will not cancel out to give me an answer of 0. If it is not giving me an answer of 0, that means it is not a factor. It will give me a certain remainder. The question is finding out that remainder. So if I just complete the things that you have, so if you just look at the values that we have here and add it up to get to the value of 316, which is coming out to be our remainder. So when this is divided with x plus 4, or when I put the value of x is equal to minus 4, the output, which is the remainder, is coming out to be 316. Let's move ahead and let's look at the second topic, which is the topic of polynomials. Polynomial, as I've already explained a little bit, means many. Poly means many and nomial means terms. So when many terms are combined, what you get is a polynomial. So let's get started with polynomials. Polynomials can be categorized as linear polynomials, quadratic polynomials, and cubic polynomials, and certain other polynomials, but we'll just concentrate on these three for the time being. Linear polynomial means the degree of this polynomial would be 1. Quadratic polynomial means the degree would be 2. And cubic polynomial means the degree of this thing would be 3. I have no clue about the number of terms or the number of variables. The number of variables could be 1 or could be 2, could be 3, and so on. So if I have to write a linear polynomial in one variable, it'll be something like 3x is equal to 6 or 3x minus 6 is equal to 0. So something like one variable and degree also 1. If I have to write it in two variables, it will be something like 2x plus 3y equals to 6. I have two variables, but the power or the degree would be 1. For a quadratic, degree 2, I would write something like x square. I can have a coefficient for this. Now the degree is square. That means I can have a term with 1 power. I can have a term which is constant. So I can have 2 terms. I can have 3 terms. I can have a single term, 4x square. Monomial, binomial, trinomial, depending upon the number of terms. But the highest degree, or the highest power I should say, has to be 2. If I have to write a cubic polynomial, it could be something like x cube. The highest power has to be 3. I can have the lower powers also. I can have a term with no power. So it could be 4 terms, it could be 3 terms, 2 terms, or single term x cube, depending upon the number of terms, but the highest power has to be 3. So this is how we can write, and we'll discuss them in detail. So certain formulas that I need to remember when I'm looking at the case of polynomials. The first formula is a plus b whole square. Expansion would be a square plus b square plus 2ab. A minus b whole square, it will be a square plus b square minus 2ab. A square minus b square, it will be written as a plus b into a minus b. A plus b whole square plus a minus b whole square. So it will be a square plus b square plus 2ab, a square plus b square minus 2ab. That plus 2ab and minus 2ab would get cancelled out to give you 2 times a square plus b square. The next that you have is a plus b whole square minus a minus b whole square. So if you look at it, the 2ab thing that got cancelled out the last time would be actually added this time to give you a value which is 4ab. A plus b plus c whole square would be a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So this is the expansion that we have for a plus b plus c whole square. Let's move to the cubic parts. A plus b whole cube. So it will be a cube plus b cube plus 3ab into a plus b. Or if I look at it, a cube plus b cube plus 3a square b plus 3b square a. Now the thing that you need to notice is when it's a cubic expansion, every term will have a power which is equal to cube. If I look at it, a square b, there are two variables a and b. If I combine the power, it is 2, it is 1. So the total power for this is 3. 2, and again if I look at it, this is 1. So the total power that will come out to be will be 3 that I have. A minus b whole cube, it will be a cube minus b cube minus 3ab into a minus b. So if you want to expand it, it will be minus 3a square b plus 3b square a. A cube plus b cube would be a plus b into a square plus b square minus ab. A cube minus b cube, it will be a minus b into a square plus b square plus ab. A cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. And if a plus b plus c is equal to 0, so that means if this term is 0, the right hand side would be 0. So the left hand side would be a cube plus b cube plus c cube is equal to 3abc. So these are the expressions that we need to remember. You can take as much time as you want. You can pause here, learn all the formulas, and then go ahead with the questions based upon these formulas. Let's look at the questions. So the first is, if the value of x is minus 2, y is minus 3 and z is 5, then what is the value of x cube plus y cube plus z cube? So if you look at it, you can directly put in the values here. What is the value of x cube? X cube is minus 2 cube, which will be minus 8. Y cube minus 27. Minus 3 cube, which will be 27. And z cube, 5 cube, which will be 125. Now if you add all these values, it will be 125 plus minus 27 plus minus 8. So if you just look at the values and solve them, you will get your answer for this expression, which will be 90. However, I can apply the formula that I have just learned. So if I go back to the formula sheet and look at the last formula, the last formula that I had was a cube plus b cube plus c cube was equal to 3abc if a plus b plus c is equal to 0. And if I go ahead, now if I look here, the value of x plus y plus z, which is what? Minus 2 minus 3 plus 5 is 0. So x cube plus y cube plus z cube will be actually equal to 3x, y, z. So if I just put the values 3 minus 2 minus 3 and 5, the minus thing would get cancelled out and the answer that you would get would be 90. So any ways that you want, you can solve the question. You can apply the formula or you can put the values and get to your answer. Let's look at the next question that we have. If x square plus 1 by x square is 66, then the value of x minus 1 by x. So let's look at the equations that we have. So if I look at x minus 1 by x whole square, the expansion was x square plus 1 by x square minus 2ab. So this is the formula x a minus b whole square. It is a square plus b square minus 2ab. So if you look at it, this thing would get cancelled out. The value of this is already known to you, which is 66 minus 2, which is 64. So this square value is equal to 64. If I take square root on both the side, x minus 1 by x, the value would be 8. So 8 is the answer that I get for this question. Hope you are able to apply the formulas now. Let's look at the third question. If the sum and the product of two numbers, let me take the two numbers and x and y. Now what is given is the sum of two numbers is 10 and the product of two numbers x and y is given to you 24. You have to find the sum of their squares. So that means the question is asking you to find out x square plus y square. There are 2 or 3 ways that you can do the question. Let's first apply the formula. I know the formula for x plus y whole square is x square plus y square plus 2xy. Now I know the value of x plus y square, which is 10 square, which will be 100. This will be equal to x square plus y square plus 2. Again I know the value of xy, which is 24. So this will be 100 minus 48, which will give you the value of x square plus y square as 52. This is applying the formula. The second way that you can do is just by breaking this thing. So if I look at it, x could be 1, y could be 24, this will be 2, this will be 12, this will be 3, this will be 8, this will be 4, this will be 6, and again the same thing would repeat. This will be 6 and 4 and 8 and 3 and 12 and 2 and 24 and 1 and so on. So I look at the first. I find out the value of x plus y. 25, 14, 11 and 10. So that means this is the case. The value of x and y is 4 and 6. So if I just find out the value of their squares, 4 square it is 16 and 6 square it is 36. So if I just look at the answer still that I get is 52. So I can either apply the formula or I can do the questions without the formula, whichever way you like. Let's look at the next question. The question is, if a plus 1 by a is equal to 1, then what is the value of a cube plus 1 by a cube? Now I need to know the formula for a plus 1 by a whole cube. So the formula is x plus y whole cube. What was the result for x plus y whole cube? The result was, it was x plus y, x cube plus y cube plus 3xy into x plus y. So if I just put the values, it will be a cube plus 1 by a cube plus 3a into 1 by a into a plus 1 by a. So this a and 1 by a would get cancelled out. I know the value of 1 plus 1 by a, it is 1, is equal to a cube plus 1 by a cube plus 3 times again it is 1. So I just look at the values and I will get the value of a cube plus 1 by a cube as 1 minus 3 as minus 2. So that is all that we have in lecture 1 on algebra. Please continue to lecture 2 for understanding the topic of linear equations. You can also move to our website now and practice more questions on quadratic expressions and polynomials. Thank you so much. Have a nice day.